to start off, and then I'll pass the baton to Brent. And what I wanted to cover today was a report that we just finished or just published in partnership with the Ecological Restoration Institute. That's an overview. It's the third year we've done this overview of the past fire season. And it looks at 12 of the largest fires from 2015, and they're labeled here with their names on the map. And then you'll see a lot of little X's. Those are the smaller fires. We looked at all fires above 4,000 acres, so trying to get with the fewest number of fires, the largest number of acres. And notably, 2015, there wasn't as much wildfire activity overall, not as many acres burned. There was a fair amount of prescribed fire. So if we look at this chart, we can see that we've had since 2011, which obviously was a bad year for wildfire acres, we've had a significant drop, and it's been below the sort of 10-year average more recently. The other change that happened last year is sort of this administrative bookkeeping change, but it makes a difference for how we understand these fires and, for me, how I try to record them. And I have up some segments from the NIFC's National Incident Management Situation Report, how to read it. They've put out this document early on. And the key thing is they started to include language about fires managed with strategies other than full suppression. And I think for those folks on the ground who worked on fire management, this was sort of part of the job for a long time. But in terms of bookkeeping, some of it became a little bit opaque to those of us not on the fire. And the new record keeping is such that it recognizes that on any given fire, there may be part of the fire where the full suppression strategy is what's used and most appropriate, and other parts of the fire where maybe a confine and contain or point protection is used. And now the statistics reflect that. And this, of course, has to be put in the context that in many federal government rules and regulations, really there are only two kinds of fire: prescribed fire and wildfire. But I think it's important to recognize how these strategies are playing out on the ground, because it makes a difference for how they burn, how we experience those fires. So forgive me if that's a little more detail than anybody wanted. But so thinking a little bit of all the way a year ago about the sort of environmental conditions, the weather conditions for the 2015 fire season, this is a graph of the energy release component that actually Chuck Maxwell produced, one of Brent's colleagues. And probably the most important thing to notice about this graph is the blue line, the 2015 year, is below, certainly below the maximum, the red line, but even below sort of the 10-year average for much of the key portions of the fire season. So we don't need to go into the mechanics of the energy release component and how that's calculated, but the real point is here that we didn't have the conditions for big wildfire blow-ups last year. And we'll see that as we dive into these individual fires. And I'm going to run through these in a very quick way, but if you want more details, you can access the report that should be on the ERI website as of today and is on the Forest Guild website and will be on the Southwest Consortium website soon. But if you can't find it, just drop me an email. So we'll go by order of size, and I'll start with a whitetail. This was about a 34,000 acre fire that was lightning ignited and burned on tribal land. It also won an award for the 2015 Incident of the Year in combination with another nearby fire, the Sawmill Fire. The San Carlos Apache Tribe and BIA San Carlos Agency did a great job in managing these fires at the same time during the 2015 fire season. And the Southwest Fire Science Consortium wanted to recognize the good work and the planning efforts they put in place before the fire and the good work on the ground during the fire to really ensure that the beneficial impacts of fire were maximized safely across the landscape. So partly I mentioned this to give the managers of the whitetail and sawmill fire some credit for the good work they did, but I also mention it because if during this coming year you're involved with fire management or hear about a fire where folks are making decisions and putting implementation on the ground that really helps get good fire across more acres, we want to know about it and we want to recognize that good work. So the whitetail fire burned mainly in pinon and juniper with some chaparral and conifer oak or grasslands. And you can see from this small map that it burned through a lot of an area that burned in 2009 in the Bear Canyon fire. It burned right up against the skunk fire as well from 2014, the previous year. So the whitetail fire burned in this matrix of past fires and in an area that's beginning to have some real fire return interval of that it's more reasonable. We don't have, I guess I should say before I go on, we don't have, for a number of these fires, we don't have the burn severity information. There are two burn severity maps we use for most of this reporting. One is the soil burn severity map, and one is a canopy canopy mortality map. Both use satellite images, and neither were available for the whitetail fire, which is somewhat of a data gap, although we know from anecdotal evidence that burn severity was generally fairly low across this area. The next fire in size was a 24,000-acre lightning-ignited fire called the Camilo fire. And you can see somebody doing some burnout work here on the Camilo. And from the canopy mortality map, you can tell that most of the area burned at very low severity. There are a few pockets in here, and you can sort of see them as little red blips here on the map, but those patches are pretty small, and overall probably within this ponderosa pine forest type in which it burned, probably appropriate to have some small openings like that. The Red Canyon fire was the next fire in size. It was about an 18,000-acre, also lightning ignited. Most of the fires we'll talk about here from 2015 were lightning ignited. And you can see it burned through, in this picture, ponderous pine, some mixed conifer with fairly open spacing. And that kind of environment lended itself to fairly low burn severity. This is soil burn severity that we're looking at on this map. And I broke it out in the graph here by forest type. And you can see that in the ponderosa pine, there was a little bit more moderate soil burn severity, so it may have burned a little bit hotter in that ponderosa pine than it did in the pinon juniper or in the grasslands. But in general, that was a fairly small proportion of the overall fire perimeter. The hog fire was the next fire in size, about an 8,000-acre lightning-ignited fire on the border of Arizona and New Mexico in the south. And the hog fire burned very near the Guadalupe fire. In fact, they shared some boundaries. The Guadalupe was about a 6,000-acre fire, lightning ignited. And you can see from this photo, sort of oblique aerial photo, that it burned through grassland, chaparral, sort of shrub environments. And using the land fire map and some of the burn severity mapping, we can see that where it burned the hottest or had the greatest canopy mortality tended to be in grasslands. So that concept of canopy mortality is a little strange in grasslands, but it's also likely to have less negative long-term effects because obviously we're talking about annuals rather than trees. And we also see in this mapping that the pinon juniper had some acreage of greater than 90% canopy mortality on the hog fire. And in the Guadalupe, it was somewhat similar, although smaller patches of complete canopy mortality. Another item to note on the hog and Guadalupe fires is they again burn into past fires. The 2015 hog fire burned over portions of a 2009 fire, also called the hog fire. I tried to highlight it in yellow, and then on the eastern edge, the Whitmere 2008 fire burned along here. Starts to get confusing to try to illustrate the various fires as they overlap, but hopefully that's intelligent for folks. And you can see where the Guadalupe fire met the hog fire there, where the perimeters overlap. So they burned at different times, but otherwise they could have been considered one fire probably. As we get down to the Springs fire, there's actually less information available about some of these smaller fires. The Springs fire was about a 7,000-acre lightning-ignited fire. We do have some canopy mortality data for the Springs fire, and 93% of the fire area had less than 25% canopy mortality. Again, like the Camilo, you can see it had small patches where there was complete or high canopy mortality, but overall most of it had fairly low canopy mortality, which is appropriate and matches the forest type, the ponderosa pine forest type that dominated the area. As I mentioned earlier, the sawmill fire was sort of a pair with the whitetail much smaller, but as you can tell from the map on screen, it covered area that hadn't been burned previously within this matrix of recent fires on the San Carlos Apache Nation. And it did burn in connection with the 2014 spring and 2012 Indian fire on the sort of southeastern edge. Again, we don't have soil burn severity maps or canopy maps for the sawmill, but anecdotal evidence is that it burned with fairly low severity. The next fire in size is the Northcut fire, and this is somewhat of an anomaly in the reporting. It's a grass fire, and it burned through mainly shortgrass prairie out in eastern New Mexico. And we don't even have a particularly accurate perimeter, but we have the location, and you can see that it's a mix of shortgrass prairie and some agricultural lands that it burned through. But this was managed with a full suppression approach, although I'm not sure. I think the ignition source was never identified. The next fire, similar size, about a 5,000-acre fire. The Playground fire was lightning ignited. And again, we don't have good perimeter data for this fire, but we know it burned in this area with a mix of conifer oak, some ponderosa pine, some pinon juniper. And we don't know a lot about the severity of this fire either. The next two fires, the Rattlesnake and SAL Hill fires, were similar in size. Rattlesnake was a little bigger, about nearly 5,000 acres. Both were lightning ignited. Both burned in sort of a grass, scrub, and chaparral, although SA Hill fire had a little more pinon juniper. And the SA Hill fire was managed with a full suppression approach. And that may have been, although I'm not sure, that may have been because of some of the human development that was nearer the SAL Hill fire. Well, the Rattlesnake was farther from human development. The last fire that we'll cover here was the Jar Complex. It was a little more than 4,000 acres, lightning ignited. This is a pretty classic photo, low flame lengths burning through ponderosa pine, pretty nice. And you can see that the jar complex really fit like a puzzle piece into a matrix of past fires. It burned over a fair portion of almost all of the 22 wildland fire use fire from 2008, and sort of filled in between the Mutter's Back and the parallel fires, or those perimeters. And, I guess I should note also the very low soil burn severity. Most of it fell in the unburned or very low category. So to summarize these fires, one of the notable things is most of the fires from 2015 burned in pinon juniper, conifer oak, and then sort of these scrub or grassland categories. Previous years, we looked at this, much more of the fire season happened in mixed conifer. That was not true this year. Definitely a different focus for vegetation types. When we look at the land fire vegetation condition class, this is a measure of how out of whack the vegetation was within the fire perimeter. And so this low would be low departure from historic conditions. Moderate would be moderately departed from historic range of variability. And high would be highly departed. And you can see that very little of the 2015 fires burned in areas that were mapped as highly departed. And much of the area burned in low or moderate. I personally was interested to note that the Camilo and Red Canyon both burned in vegetation that was moderately departed, and based on the soil burn severity maps, my assumption was that these areas will probably, next time they're reclassed, would actually end up being more close to historic range of variability because of those fires. When we look at those fires for which we have canopy mortality mapping, most fell in the less than 25% canopy cover mortality. And as we get out towards these higher classes, most of those are from the hog fire and the Guadalupe fire. And so, as we talked about earlier, those were fires that burned through grassland and shrublands. So some of the mapping there, I personally would like to, before making a lot of judgments about those canopy cover data, I'd want to see on the ground what it actually looked like. The same is true for soil burn severity mapping. Those fires for which we have data and we don't have data on the whitetail or the sawmill or the playground. So there are a lot of fires for which we don't have data, but you do see that the high category here dominated by the hog fire and the Guadalupe fire again. So I'll go easy on the interpretation, but I think that it's interesting just to note that right off the bat. The last thing I want to cover before we turn to an outlook for the coming year with Brent is fire cost. So the first thing to think about is, well, how big fires, how much do they cost? And it's not surprising there's sort of a connection. The bigger the fire, the more they cost. But probably more informative is if we look at the per acre cost. And then obviously the whitetail covered a lot of acres, but actually it was less than $100 an acre. Similar Camilo, Red Canyon, both management costs less than $100 an acre. We see some of the more expensive fires out here. SA Hill fire and the Guadalupe fire, more expensive. And I think it's maybe not quite fair to highlight, but might bear further thinking that the SA Hill was one of the few fires managed with full suppression strategies in the past year, in 2015, I should say. Other fires, the Northcut was actually relatively inexpensive, but also managed with a full suppression strategy probably connected to the fact of burning grass. I think with that, we can talk more about this look at last year in the question and answer, but I want to make sure we have plenty of time for Brent's presentation. And I'm really pleased that Brent was able to get on the line with us today. He does great work for the National Weather Service, and one of the things I particularly like that I think he'll show us today are some of his year-to-year comparison photos based in the same place. But Brent has a lot of great experience that he brings to the topic. He has a Bachelor of Science degree in Atmospheric Science from the University of Wisconsin. He worked for a private company providing meteorological guidance into agriculture and energy traders around the world for a couple of years in D.C., and then he came to the National Weather Service in 1998 and became a fire and incident meteorologist in 2001. He currently resides in Albuquerque, and he's been on over 60 fires across the western U.S. and Alaska. He's been attended or participated in doing some meteorology in Australia for the Victoria Bureau of Meteorology during the Black Saturday firestorm event in 2009. Brent actively trains firefighters and meteorologists and is a current member of the NWCG Fire Behavior Subcommittee. And as you'll be able to tell from this presentation, he's passionate about all things fire. And so it's really great to have you on the line. And the next thing I got to do is give you control, and then you can take it away. So
okay, I see it. Thanks, Zander. A great presentation. It kind of leads into my presentation because, what happens in the past can sometimes foretell the future. And I've heard already, I was just on the Coyote fire just a week or so ago, and there was a lot of comparisons, people talking about what happened last year in terms of the precipitation patterns the past couple months and what's been occurring thus far. So always looking at historical is good in terms of looking out ahead. And so yes, I was asked today to give a fire season outlook. I started doing these presentations back, I guess it was November of last year for the State Foresters meeting in New Mexico, and of course this outlook has evolved and been massaged over the past few months. And now we're kind of leading into what is notoriously the heart of the fire season for the Southwest. Memorial Day through July 4th, I would consider the kind of the peak period, certainly when usually fuels are the driest, and we just have different combination factors there. One thing to add, and I'll talk about this a little bit, so you see this picture, there's a lot of grass, and I think, with the fine fuel component, has been a game changer thus far for this fire season. We had a pretty active, what I call pre-season or pre-green up season, at least in New Mexico, and I believe it was also going on in Arizona as well. Because of the grass fuel loading, people that were burning ditches in February, March, some people were losing their fires, and even on non-windy days, because of this abundant carryover fuel that we had from last year. So we've already had a fire season in the Southwest. It's always ongoing, but it ebbs and flows, and certainly I'll be talking about the future over the next month and a half. Okay, so we'll go forward here. So I'm going to be, these outlooks, these presentations, they follow along very closely to what SWIC, the Southwest Coordination Group, what they do, the predictive service meteorologists like Chuck Maxwell and Rich Naden, they put together these outlooks starting at the beginning of each year, and they tend to update them. I follow along very similar to what those guys do, and I call it the SWIC's Big Five, and this is what really drives and sets up the fire season each year. And obviously they change each year. Drought, fine fuels condition, winter temperature and precipitation, the weather patterns during the spring, the early summer, and then finally what typically ends the main part of the Southwest area fire season is the monsoon, and when the wet portion of that monsoon sets in. or the summer pattern. So we'll be spending a few slides for each of these as we go forward. Okay, so drought status. This was an interesting topic because we've been dealing with drought, I think at least for New Mexico, we had been in drought status ever since like 2010 was the last time that we didn't have some portion of the state in some sort of category of drought. And you can see the categories there. There's D1 through D4 with varying degree of intensity. D0 is abnormally dry, or the yellow color. And so New Mexico, anyway, had been in a moderate drought or worse since around 2010, sometime in 2010. And earlier this year, we had fell out of that. We just had abnormally dry areas throughout the state of New Mexico. There was still a residual impact of drought in Arizona. And unfortunately, February and March came around, and for a good part of the southwest area, we'll talk about it, precipitation was really light. So we had to go back into a little bit of a drought status. And these are graphics that show drought around the same time last year compared to this year. And you can see, and see if I can get my little cursor going here, the intensities of the drought are just not the same as they were going into the fire season last year compared to this year. And so we have more intense drought that we had last year. It certainly has shrunk a little bit, but I think the key part of this is the drought intensity has improved. And in fact, these charts come out once per week, and the new one will come out tomorrow. And there's going to be parts of the, well, right where I have that arrow cursor, that's going to start to get shaded back to abnormally dry from moderate drought. So we're going to actually see, because of recent precipitation, that the drought isn't going to be quite as intense going into the main part of the season as we had last year. So that's definitely a good sign, and it's a good sign for many factors, and we'll talk about that. Okay. Now, fine fuels. Fine fuels in the southwest area is a big driver of fire, whether it's large fire growth or just as it moves around across the landscape. And I think this is a great picture. So yes, Zander was correct. I go out around the same time every year, at the same location. Been doing this for at least 8 years. And this was a picture taken just above Los Alamos, right by the ski hill, and it shows carryover fuel conditions, or antecedent fuel conditions. Looking at October in 2013, you can see what the growth was following that growing season and compare it to the growth following last year's growing season or the previous years. And I would contend that it's not just last year that is built up, but it's the last 2 growing seasons, whether it's been in the spring or in the summer, that we've built up quite a fine fuel bed. And I think this is very valid based on talking to people across a good chunk of the southwest area, especially the southeastern half of Arizona into a good chunk of New Mexico. You'll see this type of fuel regime out there. So bottom line is we have a heavy carryover of fine fuel, which was a primary driver to the preseason or the pre-green up fire season we had this year. Okay, one thing about grass is that it can get altered, and that can be done through snowpack. And so we did have a varied winter snowpack and compaction across the southwest area. And of course, these photos are going to be more with New Mexico. And so I have Albuquerque foothills, 6,000 feet elevation. The fuel going into the winter season, the top left, November, and in the same picture taken in March, showing what the fuel, what the grasses look like. And you see that there was very little, if any, compaction that went on during the winter period. There were a few snowstorms that occurred, especially in the early part of the winter season, but grasses can suspend back if their stems haven't been broken. Now we go over to the Jemez side, and the same picture. This is up near La Cueva in the Jemez Mountains of northern New Mexico. lots of standing tall grass going into the season, and then again in March, you can see that there was definitely some snow compaction. And I was just back there just a few days ago, last weekend, and there's still quite a bit of compaction of the grass there at that location. So the fuels have been altered in some locations, higher elevations across mainly northern New Mexico. I suspect that might be the case a little bit in Arizona, but less so than New Mexico. Okay, and then what's the current fine fuel conditions? And this is what's the current 2016 spring green up. And it's a mosaic out there, and this is what you would typically find during a normal year. Is you would have a mosaic of green up based on aspect, elevation, and latitude across the southwest area. And green up, whatever that did occur across the southern tier of the southwest area is done, at least for cool season grasses. And based on talking to people, it was either near normal or probably could even say slightly below normal because of lower topsoil moisture levels. The green up across central and northern portions of the region, that's where we're talking about near to even a little above normal, thanks in part to some of the recent precipitation that we've had in April and May. And I'll just actually show you some pictures where we're at here. This is Arizona. This is pictures taken just a few days ago, some that I was able to get off of the InstaWeb from some of the incidents that are going on. And then Tom Bird, a fellow incident meteorologist down in El Paso, was, I think, vacationing in the Apache Junction area. And so you can see that further south, Coronado National Forest, a lot of the herbaceous or the grasses have cured out. Yeah, they basically cured out, almost 100% cured out lower elevations. Further north you go, it's a mix. If you're in the lower elevations, say around Phoenix, the Tano Basin, the grasses are primarily cured out. You go higher in elevation, and it's a mix of curing, especially at more the Mogollon rim level, above 7,500 feet, 7,000 feet. And the further north you go, where the precipitation has been a little bit more, like the Coconino National Forest, there is a lot of what we call green belts out there, very green and lush. And I should also mention in the Apache Junction photo, notice, and even in the Coronado National Forest photo, notice how green some of the shrubs are. Certainly they're starting to cure a little bit, lose their live fuel moisture levels, but they're still vibrant green. And I spent a lot of time over in Arizona in different fire seasons, drought-stricken shrubs where they hardly ever even greened up. So this is a good sign, at least for the health of the landscape, to see these green shrubbery or green riparian areas. As far as New Mexico is concerned, it is. It's a lot like Arizona, but perhaps even a little more lush in terms of green up. It is a mix out there, and the further south you go in New Mexico, and especially in the lowlands, the grasses or herbaceous are cured or curing out very quickly. The further north you go, it's in that transition of curing, and up in the northern part of New Mexico, the flush of green is really underway. And with these sunny and warmer days that we've had, that's what really the green up responds to. And it had been cooler and cloudier, and so it probably stalled just a little bit, but now the vegetation has taken advantage of the topsoil moisture and the subsoil moisture and greening up very well. Once again, looking down south, the Guadalupe Mountain picture, this is on my way to the fire, you can see lots of greenery there in the shrub class. Of course, the herbaceous are cured out, and again, a good sign, because I've done fire in that area before, and I've seen the shrubs not looking too good, very drought-stricken, but this is just a different year. So we talked about the fine fuels, very important in terms of how it impacts the fire season. Winter season, what happens in terms of precipitation, very important too. It really links to how long the main season is going to be. The snowpack goes off quickly. Typically the season becomes a little longer, exposes the fuels to radiation, and they dry out pretty quick. And this winter season was definitely an interesting one. You know, we had an El Nino from last year going into this season, and in all regards, precipitation was expected to be above normal in the southwest area, a good chunk of the area. And it was highly variable and based on space and time. And I call it was front-loaded, where we had a lot more precipitation during the fall in the southwest area, into the early winter, even up through the earlier half of January. And then pretty much the spigot just got turned off. March and February were really horrible. The jet stream had lifted northward, and we were just on the dry side of the system passages. And you can see from the chart, I put in two charts here. We have late December to late March, and it was just pathetic across the southwest area. But if we started looking at late September to late March, you can start to see now where the storm track was a little further south and really benefited New Mexico pretty well, and even into West Texas and parts of Arizona. So, you know, it was a tale of two seasons in terms of winter. And that meant, in terms of snowpack, I have, these are SNOWTEL data from the NRCS, these gauges that are up in the high mountain areas that are basically collecting water for runoff purposes. But we can use it to help predict fire season as well and tell the state of fire season. And you can see, at least from water year data, which starts October 1st, precipitation from October 1st through the end of the winter season was near normal across the southwest area in terms of the mountains. But the water in the snowpack is very important. And by the end of the winter season, there was below to well below normal water in the snowpack, which meant that basically the snowpack was going to go away fairly quickly and could set up an early fire season. And that was the thought process that some people kind of took. However, then the spigot turned back on, and the jet stream dipped back to the south. And there's various reasons why this happened, but El Nino never went away. The above normal sea surface temperatures across the equatorial Pacific, they were still there. It was just things happened, and how the gradient of those sea surface temperatures, how they behaved, became more pronounced in the spring season and allowed the jet to dip further south. And you can see from the storm track, the left image is the percent of average precipitation. Blues and purples mean above normal precipitation. And you can see that a good chunk of the southwest area started to receive moisture again, and above normal moisture. The departure from average temperature, also temperatures were cooler than normal during the same period of March 23rd to May 19th. So that basically kind of stalled the fire season from getting, I guess, out of hand in a certain sense in terms of wildfire. And we started getting less and less starts. Wildfires didn't grow as well. They weren't as active, weren't as hard to control, and so things turned around pretty quickly there. And that was largely tied to temperature and precipitation and green up. So Zander it showed a graphic, the energy release component. This is a graphic from the same group, from the Predictive Services group, the SWIC's webpage. It's for 12 stations across Arizona and New Mexico. I believe there might be a West Texas station in there. And I think, you know, ERC, energy release component, very great proxy for determining fuel dryness out across the landscape. It is a drought indicator, and it really shows you how weather impacts the fuel conditions out there. And you can see this solid blue line. It's the current trace for this year, 2016. You can see how it rapidly goes up, and that's because of March and February being so dry and warm. And then right around that first week in April, it takes a huge dip to where the fuel conditions became much more moist and not as critical. It was getting near the 90th percentile. And if you've used these charts before, land agency personnel, they start to pucker up a little bit more when that line starts to get near 90th percentile. And somewhere between the 90th and 97th percentile, sometimes forests will start to go into restrictions. It depends on other aspects to that, but they look at these ERC charts to determine sometimes these restrictions. And so definitely things took a hit. And then you can see these wild, what I call roller coaster types of swings based on these moisture intrusions. So we basically were starting to get these timely moisture intrusions, April and May, and they were starting to punch holes into the fire season where it wasn't as critical. And this is ending May 23rd, so you can see that we're, as a whole across the region, around 60th percentile, which is pretty low for this time of year. And it's actually, the gray line is below the average line. So we're sitting pretty good. The other thing about Southwest fires is wind. If you can predict the wind, you can partly predict the fire season. And this is a chart that it's for 10,000 foot winds and wind speeds. This is for April 1st to May 20th, and typically our windy season is March, April, May in the Southwest area. And a large part of the Southwest area in purple and blue is below normal in terms of wind speeds. And this is, I think 700 millibars is a good proxy for wind speeds at the surface because a lot of our wind comes from aloft, through the mixing of each afternoon. And so as much as 7 miles per hour below normal in central New Mexico for that spring period. So, we have had wind recently, and it's just not as critical wind as we saw, say, back in 2011 when we had a La Nina going on. So that's something to kind of keep track of in terms of the severity of fire seasons. Okay, so I just spent the last, 20 minutes talking about everything building up to the main part of the fire season. So what's going to happen in June? That's, the heart of our fire season. Well, one, I think we're going to continue to see plenty of lightning, especially across the northern and eastern part of the region. We have been seeing that recently, probably not quite as much lightning as we saw last year, but pretty close. As far as wind speeds, which again is very critical for the Southwest area, I don't see anything that would suggest above normal wind speeds through the month of June. I would expect it to be more normal. And what that means is typically red flag events, which are tied to wind, and are issued under critical conditions for fire weather and fuels, and it's what makes fires spread pretty significantly. Those types of red flag events should be winding down after the first, maybe even second week in June. And so there shouldn't be anything abnormal. Back in 2011, if you remember, we had red flag events going well into June, even up into the latter part of June. June 26th, Lost Conscious fire start, that was under a red flag event. So we're not seeing anything like 2011 in terms of wind speeds. In terms of precipitation, this is the charts from the Climate Prediction Center. There is a better potential for above normal temperatures during the month of June. Thus far this spring, it's been below normal, but we do expect conditions to get warmer as we get going, and even to the part of getting above normal. And then precipitation-wise, at least from the Climate Prediction Center, there isn't a lot of, it's harder to say whether it's normal, above normal, or below normal. So they're using pretty much equal chances across a good chunk of the Southwest area. Now that is somewhat debatable. If we looked at some of the deterministic models, at least for the next 2 to 3 weeks, we're going to see a similar weather pattern that we have been seeing, and that is these timely moisture intrusions, most likely for northern parts of the region and eastern parts of the region where the dry line is a little more active with the wetting thunderstorms. So the pattern that we have been seeing the past few weeks with these disturbances coming through, higher humidity, cooler temperatures, some precipitation, that should remain at least for the next 1 to 2 weeks, at least into the earlier part of June. There's various different ways that we can make these outlooks. We can look at the past, which is analog years, to predict the future. That's one way. We can also look at the dynamic climate models that are looking at various things going on in the ocean, decoupled ocean and atmospherics. And there's this webpage that is hosted by the Climate Prediction Center that has been constructed here in the past few years that allows meteorologists to better predict the future out even several months out. And so this is a screen capture of forecast made in May. I think it comes out, these forecasts are updated around the first or second week of each month. And there's all these different dynamic climate models that are out there. This page contains at least some of them. And you can start to use the solutions, and this is precipitation, by the way, to, in conjunction with analog years to make a prediction. And the green colors represent and blue colors represent above normal precipitation, and this is for the month of June. And the red colors and brown colors represent drier than normal conditions. The Climate Prediction Center and the forecast that we just looked at, and you may not see this very well on your computer screen, but that the CFS version 2 is the one, and this is, now let me use my highlighter here. I'll just kind of circle it. Well, I don't know if it worked. Anyway, that version of the model is what they heavily rely on when they do their monthly and seasonal outlook. So if we go back to the precipitation, this mimics that graphic pretty well, where it's more normal conditions across, say, southern parts of the southwest area. And I think the green that you see showing up, that's where that storm track, the battle of the haves and the have-nots, or the dry versus the more moist conditions with the current storm track that we're having. I think this version looks pretty close to what I would anticipate for the month of June. The solid black lines around these different models, they represent the highest skill scores based on a May forecast for the month of June. That's the problem, because if you take the best performing model, or models, the top three anyway, there's some pretty distinct differences. The GFDL in the lower left has much drier than normal for the southwest area as a whole versus the NCEP CFS version 2. And then the NMME is a composite of all of the climate models that you see in this webpage. And it basically shows equal chances or normal precipitation for the southwest area. So there's a little bit of uncertainty there. If you saw analog years and you looked at the analog years and you looked at the climate models and they all said the same thing, well, then I would have higher confidence in what I'm saying. But if there's mixed signals, then the confidence becomes a little less. But if I was a betting person, I would be betting on that NCEP CFS version 2 for the month of June. Okay, and then lastly, the summer monsoon season, and that's really crucial. We talked about winter snowpack and when that comes off and how it determines the length of the fire season. Well, the summer monsoon also determines the length of the main fire season. It's typically what ends the fire season as a whole across the southwest area. And based on everything and looking at the climate models and looking at analog years, and there's a few analog years out there, there isn't any evidence that suggests an early or late onset to the monsoon. That it should occur within a few days of what's on this graphic, and that is the median dates for the end of the large fire season. And this is a graphic courtesy of the Southwest Coordination Center looking at humidity levels. And you can see that out in eastern New Mexico, it ends earlier, and then the latest is out in western Arizona based on what the monsoon typically does in a normal year. And so a lot of people use the first week in July as kind of that proxy or time period that the monsoon sets in. So right now we don't have any evidence that suggests early or late. As far as the monsoon season, the generally July, September, or July, August, September, that's more of the wet phase of the monsoon. The climate models are indicating, and they varied a little bit, but they have indicated that the monsoonal plume, the main moisture plume that originates from south of here, from Mexico and the Baja and the Gulf of Mexico, that plume would reside more over Arizona initially during the month of July in western New Mexico. And then as we progress through the summer into August and early September, that plume would shift a little bit further to the east and reside more over in New Mexico and a little bit of West Texas. It undulates back and forth, as we know, during the course of the summer, but that's at least what the dynamic climate models are showing, and I'll show what they're saying. This is, again, the May forecast. This is for July, August, September, and the highest performing models, again, are the solid block boxes that I have, and we have the NASA GOS, and then we have the CMC1 from the Canadian government, I believe, and then the NME. And again, what do we see? We see conflict, at least a little bit. We see a little more green or above normal precipitation from the NME and then the NASA model, but then drier for the CMC. There's some uncertainty with this, but it largely ties to what's going on in the equatorial Pacific. Yes, we have above normal temperatures, and this is as of May 3rd. We have above normal temperatures at the surface across a good chunk of the area there, the equatorial Pacific. But if you go a little lower in depth, there is a lot of cooler than normal water. And that water eventually is going to upwell and replace the warmer than normal water and eventually lead to our high potential of La Nina later in the year. But how this water upwells and replaces the warm water has big implications to the summer monsoon season. There's various feedbacks that go into that, and if you have more questions, you can certainly ask me. But the way that it's evolving right now, and one of the reasons why we developed such active storm track during the months of April and May has been the evolution of how this water has been moving up to the surface. It's allowed a lot of big and deep thunderstorms to organize and develop in the equatorial, especially the eastern equatorial Pacific, which allowed us to draw, or allowed the atmosphere to draw the jet further south and that kind of thing. And so the evolution of this is going to be very important, and we're going to be watching very closely. And it also has implications for the rest of the western fire season as well. It makes it kind of a tricky forecast for the rest of the West. So in summary, for the Southwest area, and these are graphics that I took from the latest forecast from the Predictive Services Group, including Chuck and Rich, is that above normal, and this is tied to large fire growth in terms of large fire size, large fire growth above normal across the southern tier of the Southwest area, which is what we've been kind of basically seeing, and then more normal across the northern tier and eastern tier. And that's for the month of June. So kind of what we've been getting is going to continue. And then for the July and August period, you see just more normal status for the Southwest area. But you also will see the red migrating northward. And I would contend that by the month of August, that some parts of, say, eastern Washington, eastern Oregon, Idaho, and western Montana would be under the gun in terms of large fire growth. Kind of similar to last year, but I think probably shifted just a little bit eastward. And again, that kind of depends on what happens in the equatorial Pacific. And with that, I guess the only other thing I can add is that there's going to be a lot of variety out there, which we're currently seeing across the landscape. I don't think there's going to be a lot of alignment in terms of the large fire growth periods. That's dry fuel and enhanced atmospherics, which means strong wind, low humidity, unstable atmosphere. I think that will be minimal again this year like we had last year. So when you don't have these long alignment periods coinciding with dry fuels and the atmospherics, we tend to not get a lot of large fire growth days. I think that's going to continue again this year. This is going to be a great year, and Zander had talked about a lot of those examples had to do with managed fire. This is a great year for land agency people, decision makers, to go ahead and allow fire to grow naturally on the landscape from lightning fire starts. There's going to be I think there's going to be certainly a lot of lightning out there. And that will help with natural ignitions. And we've already seen that to a certain degree. The green fuel barriers also exist, especially across the northern half of the southwest area right now, and will continue to exist depending on elevation and latitude going through the month of June. So these green fuel barriers allow land managers to kind of hang up the fire, if you will, and create barriers for spread if they don't want it to spread in certain areas. ERC values, we just showed the chart. They're not expected to get into the extreme category for very long. They're not expected to be in the 90th percentile for weeks and weeks at a time. Perhaps in the far southern areas, which is where the above normal fire activity is expected. And again, I talked about that there's less of a chance of large alignment windows in terms of temporal and spatial for fire growth. So it's just a great year to allow fires to just naturally grow on the landscape and herd them around. So with that being said, if there's any questions or concerns, I'm willing to take them.
Great. Well, thank you so much, Brent. That was a great presentation and good overview while still diving into some of the details, so I appreciate it. And we're just about at an hour, but Brent has said he'd be willing to stick around if there are questions. If you have to drop off, I certainly understand, but if you want to type in a question, I can try to answer it, or Brent can. And actually, since there are only a few people on the line, I can't unmute the line if anybody wants to just verbally ask a question. All right. Well, maybe we're at an hour. I'm not hearing a lot of people chiming in, so maybe we get off easy today, Brent. Again, thank you so much for your presentation, and thanks everyone for participating. We'll have future webinars, so if this is your first, please join the mailing list, and you can be caught up to date on future ones. And if you have suggestions for good webinars topics, please let me know. And with that, I'll turn off the webinar and wish you all a good day. Thank you.
Cool deal. Thank you.
Thanks.